Welcome everyone. So today we shall study a new concept of the lesson gravitation, and that is inverse square law of gravitation. This is for class 10 physics. Okay, so student, this is the law which relates which show the relationship between the distance and force of attraction. So let's study the law. Alright, so before studying the law, let's understand about the centripetal force. So what is it? This we have already completed in our previous video, but let's see quick recap. Okay, so centripetal force, the force that is necessary to keep an object moving in a curved path and that is directed inward toward the center of a rotation. That means it is the force which is necessary to keep an object moving in a circular path or a curved path, and that object will be directed or forced towards in inward direction towards the center of the circular path. Okay, so this is called as a centripetal force, and we have seen one example of that stone tied to a string. Okay, this and the stone will moving along a circular path, and if we will leave the stone, then what happen, or if we will stop applying the force, what happen, the stone will fall tangentially and tangent to the circle. Okay, so this is the centripetal force. The object will forcing to inwards to the center. Alright, now let's see the inverse square law. First we will see the statement and then we will do the derivation part. Okay, so this inverse square law was suggested by one of the greatest scientists, Sir Isaac Newton. Now let's see what is the law. So the law states, as the force of attraction acting between two objects with the different masses is inversely proportional to the square of the distance between them. That means the force of attraction which is there between the two objects, okay, is inversely proportional to the square of the distance between them. Here inversely proportional, that means if the distance will increases, the force will decreases. Okay, inversely proportional means this. Now let's understand the derivation. Alright, so student, here we have an object. Consider an object moving in a circle with a constant speed. That means its velocity or its speeds will be constant, and we have seen earlier that such a motion is possible only when the object is constantly acted upon a force directed toward the center of the circle. Okay, and the force is called as a centripetal force. Just now we have seen in our previous slide, previous. Okay, so here consider if m is the mass of the object which is there in a circular path. Okay, and v is its speed. I mean v is the speed of an object which is moving in a circular path, and r is the radius of the circle, or radius of the circle, or we can say the distance between the object till the center, object and the center of a circle. Okay, so this is the distance or radius of the circle. Then it can be shown that this force is equal to F is equals to mv square r, and this is the F is equals to mv square r is the formula for centripetal force. That means the force which is acting is nothing but the centripetal force only. Alright, now here if a planet is revolving around the sun, here one planet is there, and that is revolving around sun in a circular orbit in uniform circular motion, then uniform circular motion means its speed will be fixed, in a fixed speed, constant speed. Okay, and in a circular path. So then the centripetal force acting on the planet towards the sun must be nothing but F is equals to mv square upon r, and where m is the mass of a planet. Okay, so this is a mass, m is the mass of a planet which is revolving around the sun, and v is the speed of a planet, and r is the distance from the sun. That means r is the distance of a planet from the sun. Alright, so I hope you all have understood these terms. Now let's move further. Okay, so the speed of the planet can be expressed in terms of the period of revolution, capital T, as follows. Now here what is the period of revolution? It is a time taken by a planet to complete one revolution around the sun, and we know that Earth takes 365 days to complete one rotation or one revolution around the sun. Okay, now here we need the formula for speed. Why? Because we have to calculate we will need the speed in the formula of centripetal force. Okay, so here speed will be is equals to what? Distance travel upon time taken. That means how much distance is travel in a particular period of time. Okay, now next is the distance traveled by the planet in one revolution. As we know that the planet is revolving around the sun in a circular orbit. So here we are taking the perimeter of the orbit, and the perimeter is nothing but a 2 pi r. Alright, and next is the r is a distance of the planet from the sun, or we can say the radius also. So r is the distance. Now next is time taken is equals to period of revolution, and that we have considered as capital T. And next is v. So here v will be speed, and speed is equals to, the formula is distance of travel upon time taken. So distance travel is nothing but we have taken as perimeter of the orbit, that is 2 pi r, and time taken will be capital T. So 2 pi r upon capital T. Now in next step we will using the formula of centripetal force. Okay, now formula for centripetal force is F is equals to mv square upon r. Now just put up the value of v, that is 2 pi r upon t, in this formula. So m will be as it is, and we will put the value, so it will become 2 pi r upon t the whole square, and r will be as it is. Now after squaring the v, we will get 2 pi r square, it will be 4 pi square and r square. Okay, upon r. Now here r square in the numerator and r, it will get cancelled. So in the numerator only one r will be there. Okay, and here we will write the t square, because in the formula of speed t is there na, so t square will comes in a denominator. So our formula till here becomes F is equals to 4m pi square r upon t square. Now next here we have to multiplying and dividing by r square we get. Now we will multiply and dividing the term that 4m pi square r upon t square. Okay, so here next step will be f is equals to, the above term will be as it is, that is 4m pi square r upon t square. Okay, multiply by r square and divide by r square. Now let's see next steps. Okay, so after multiplying this term, now this is a previous formula which I have shown in the box. Okay, so f is equals to 4m pi square r upon t square r. Okay, so here r square and r, it will becomes r cube. Okay, just see in the left hand side also, r and r square will become r cube, and in the denominator this r square will go with the 4m pi square. Okay, so it will become 4m pi square upon r square. Now here simultaneously you will look at right hand side and left hand side also. Okay, and in the next t square we will arrange this term in the next part. So r cube upon t square will be one side, and 4m pi square upon r square will be one side. Okay, now here according to the Kepler's third law. Now student, what is the Kepler's third law? So this is the square of its period of revolution around the sun. It will directly proportional to the cube of the mean distance of a planet from the sun. So here we have removed the proportionality sign, and we have written here constant k. So this is our equation number 1. So okay, so this equation number 1, that is f is equals to 4m pi square upon r square. Okay, so just r cube upon t square, here we are writing as k. So it will be 1 upon k. Okay, just we have to write instead of t square upon r square, r cube is equals to k. So this will become a new equation. Okay, now here in the above equation that but 4m pi square upon k, these terms are constant terms. Okay, and because 4 is constant, no value is there other, and mass is also constant. Okay, mass of a planet will be constant, and if the planet will be earth, so the mass of the earth will be 6 multiplied by 10 raised to 24 kg. Okay, and k value is also constant, pi value is constant. So these 4 values are constant, so we will write here constant. Therefore F is equals to constant multiplied by 1 upon r square. Only the radius and force will be changes. Okay, so here if we will apply the sign of proportionality, so it will become F is inversely proportional to r square. That means if the distance will increases, the force will be decreases. Alright, so this is the derivation for our inverse square law. Now next is the inverse square law of gravitation. So student, thus Newton concluded that the centripetal force, which is the force acting on the planet and is responsible for its circular motion, must be inversely proportional to the square of the distance between the planet and the sun. And Newton identified this force with the force of a gravity and hence postulated the inverse square law of gravitation. And the gravitational force is much weaker than the other forces in nature, but it controls the universe. It is weaker, but it is important, okay, as it controls the whole universe and decides its future. And this is possible because of the huge masses of planets, stars and other constituent of the universe. So student, this was all about the inverse square law of gravitation. I hope you all have understood. Thank you all of you.